We'll just wait for a few minutes and then start. In the meantime, if you guys have any questions, feel free to ask me. Okay, let's start. So, uh, brief recap of what we covered last time. The first thing is about constructor of a class. Okay, so we have a section access, right? So which is private. So the real and imaginary. So we covered that before. In the public section, you have constructors defined, which gets called whenever an object of or an instance of a class gets created. Okay. So it could look something like this. Yeah. So for a given class like complex, the constructor might look something like this. Okay. So you pass real and imaginary parts, and then initialize your member variables real and imaginary accordingly. Okay. So that is one part of it. The second is that the you could also write your constructor such that it takes default values. Okay. So here we did not have any default values, but if you give default values, then you do not exactly always need to pass any values. Okay. If you just call it without passing any values to your object, it will use those default values. That's the idea. Okay. And to check that the constructor is actually called, we print this statement. And furthermore, this was another line we added to check the THIS, this object. Okay. Basically, it's a pointer to the current object. Okay. So you can print this, and it will give different values for different objects. Okay. So the value of this is not exactly a constant across objects of a class. It depends on the object location, right? Similar to the constructor, we have destructors. So to see that it gets called, you can just put print line also furthermore, and then yeah, that also works. Second thing is that you do get to see when the constructor gets called and destructor gets called, you can print these lines. That's the idea. Furthermore, you have member functions like this norm, which returns the distance of the complex number from the origin. So the real part square plus the imaginary part square added, and then taking the square root gives you the norm, right? To see more about constructors, so we also see something called getter and setter functions. Okay. So let's say you make, so in this previous example, we had them private, right? So let's say you don't have this access to these variables, and for some reason, these members are not accessible outside the class, uh, especially when they're private. Okay. So one can actually what do is write getter and setter functions. This is also something commonly done. Again, there are other ways of achieving the same thing, but I'm just showing you guys the getter and setter function way of doing this. So get real gets the real part, and set real, for example, sets the real part. Okay. You could write the same for imaginary part also, but yeah, the idea is similar. Right. Moving on, we also saw about static function. So static qualifier. So let's say you have a variable which is integer x. Okay, so the data type gets defined as integer. But what if uh, we also specify the more qualifications that it is also static? What does that mean? So the idea is that a variable which is static, okay, inside a class is accessible across the class by all objects. Okay, it's sort of a shared variable. Okay, you can think that way, which is shared by all the members of the class. Okay, members of the class, I mean, member objects of the class. Okay, so, and it is the same value, like as it's not, when I say shared, I mean that this same x is actually shared. So when you update it for any, if you update it, if a particular object updates it, in a way you can think like it's updated for all the classes. Okay, that's sort of the idea. If you do not put the static, okay, it's just a private member, right? And each of the objects have their own copy of x. That is usual. That is the general the typical case. That's the um that's the idea. That's the it's a private member. You cannot access it outside because that's the default behavior. Furthermore, since it's private and not static, so there is a copy, uh, a specific version available for each of the objects. Okay. Next, like we have also to actually illustrate this, let's take a function called func, which sets x to 15, and a print function which updates it and then prints it. Okay. So you can have we instantiate three different objects, A, B, C of my class. Okay. And then call these values in different, like in different orders. You can comment some of them and try to guess what should be the actual output. Okay. Another important thing, this manner, that the syntax dictates that you have to initialize them this way. You have to initialize them outside. So X specifically we're using the class name as the namespace. So the namespace with the X, so specifically saying this X, we set it to 0. Okay. And it's an integer. right? Okay. And then, yeah, another my class. Uh, but this time, instead of just a member function being static, so member variable being static, we're making a member function itself also static. Okay. The usefulness of this is that you do not need to create any object of the class and then call the function. What you normally need to do, you can just use the class name as the namespace and call the function directly. Okay. So having static functions makes use of this. Okay. Because they are shared by, in a way, you can think like all the objects share the same function. So that is sort of the idea. But then the extra advantage is that you don't actually need to create a instance of an object. There is no this operator. You can actually think of this way also. There is no this operator for this class because there is no object created. Okay. But you can still use the function. Now one might think, why when do we need all this if I can just call the function directly? You don't need to create a class, you don't need to create make it static and then call it. Well, that's true. It's think of it like this is like putting your functions in a namespace. In that sense, you can think this way. More or less the same idea. Yeah. But yeah, again, you can do it either way. Right. Then we saw about uh, making like going a level further where you have a data class, right? Which is called inside the my class, where each of the data is a static member. Okay, that's sort of the idea. Okay, now the class data becomes has a member called string ID. Okay, so the reason for that is we want to use this string ID to print some stuff. Okay, and the constructor of the data takes an object ID underscore. Okay, sets it to ID. So basically, this is the construction, right? So this is where the constructor gets called. And the call of the constructor gets printed. So to suggest that this actually got constructed right now. Okay. Basically printing the ID also, right? We also define the destructor. So to see where the destruction of which object actually happens, that is sort of given by the ID. So whenever the ID prints, you know which of the object D1, D out of D1, D2, D3 gets created or destroyed. Okay. And yeah, another thing about global scope. So let's say I define a variable like this, y. Okay, in the um, it's not defined inside any function like main or inside a class or anything. It's just defined in a global in this fashion. This is called the global scope, which is accessible by all the further inside all functions and so on and so forth. Okay. You can define y equals to 3 like this. And when you specifically access the global variable y, you can give the no name, like this is sort of like a nameless namespace, but use the double colon to access the global scope. You can set it to 4 also. So it's set to 500 here. You can exactly access it here and set it to 4. So that when you set y equals to 4, it does not set the local variable y. Okay, right? Specifically here, y means the local variable y here, and the double colon y means this y, which is in the global scope. Okay, any questions? All right, let's move to today's topic. Right. Okay. So first of all, or about something about the friend function. So we saw static functions inside a class. Now, what's about this friend function? This one. Should I start first? Oh, okay, that's fine. Okay. Yeah. So as usual, we'll include the IO stream to complete the code. So I'll have my class. Just a second. Yeah. Okay. Let's go ahead. So private, I'll have, let's say, a member called data. Okay. And in the public section of the class, I'll have my class. Okay. Constructor, which takes some data. Okay. And sets the member variable data with this data. And to check the construction, I can just make constructor. Okay. Done. Right. Now, okay, before adding the main part of this one, so let's create the main function. So we'll have the my class. Okay. Create an object obj and it takes an integer data, right? Let's pass number 5. And yeah, now we'll create a function. Okay. Void display, which takes the my class itself. So it inherits, it takes the class itself as a parameter. And let's say the variable itself is A. Okay. And when I end it like this, there's no definition for it right now. Okay. But what we'll do is, let's say the definition for it, the body, okay, of it, we'll get it from outside. So which looks something like this. So okay. Now we'll provide the body. So it will be standard cout. Okay. And the data should be a dot data. Now, the nice thing is here that remember the data variable is private to the class. Okay. But you can actually access it outside if you make it as a friend. Okay. That is the key thing here. Okay. Now, what we can then do is because displays in the not, I mean, it's in the sort of a global scope, right? You can just call it like this. Pass the object. Okay. Then you're done. Okay. Let's go ahead and compile this. And it was, oh yeah, the class has spent. Okay. Right. So the constructor gets called of my class. So that's why it says constructed first. And then when we pass object and where the data has been set to be 5, ideally you should not be able to access the data member, okay, outside the class, but we are doing it. The reason for that is when you make a function as friend, okay, so its body and definition it can actually take from outside the class. Okay. So because display is a friend, uh, its signature is sort of just defined here inside, but the actual body is provided outside. So what it does is when we call this function, it takes the object, right? So object now just is accessible. Okay, that part I think is so far clear. But the reason it can access the data member, okay, like this private data, the reason is because it's a friend. So when you make a function a friend of this class, it can access even the private members. Okay, that is the key thing here. Normally, you're not there is more or less no other way to access private members of the data of any class. Okay, private member variables of any class. Okay, This is one of the only way you can think that way. We'll cover inheritance today also. There also it's not possible to inherit private. You still can't access private members there also. Okay. All right. Any questions? Right. Okay. Yeah. Let's take an example of how inheritance is defined. So this is another very important concept of object-oriented programming, and we'll look at in the context of C++. So it's sort of like building on classes itself. Okay. So yeah, let's look at what it actually is. So as usual, we have the IO stream to print stuff. So let's define a class called base. Okay. And then let's say I have private member called integer data 1b. Okay. Public data called integer data 2b. There's a third kind of uh, access. Okay. So private means it's accessible only in by the object of the class itself. Okay. Or anything within the class, you can think that way. Public, it's accessible outside the class. Protected is something I'll discuss. Okay, so I'll just take an example for that also. Just data. So it's something to do with the inheritance. Okay. So now let's look at how we can make a derived class. Okay. From base class. Okay. So this is a derived class. Now integer 1d. Okay. Remember the member variables of base are ending with p. Okay. There are three kinds, and each has different accesses, but nonetheless, all three are members. And all the members of derived class I'm mentioning with D. Okay. So here this is private because we have not specified any access specifier. So by default it is private. Then we have public, which is that's integer, let's say data 2D, and I'll define something called a void function. Here this is useful. I can use this function to refer to the object derived, okay, and then try to access the, okay? Yeah, it does not what I call it we are not setting anything to anything, so it's just an integer. We're just trying to access it. Okay. Now the key idea here is that there is a different levels of access because of this access specifiers and how derived data works. So that's what we're going to see. Okay. Inheritance is essentially this. You create a derived class from a base class so that the derived class inherits all the members of your base class. Okay. It does not mean that base class itself cannot be an object. You can definitely do that. But the extra thing that a derived class has is its own members plus the members of the base class. Okay. Right. So that is the essential idea. But what about the data that is public or protected or private? Okay. Even if you derive them and they're part of the derived class, still some of them have to follow this rule about the private, access specifiers, like the private, public, or protected. Okay, let's take some examples to actually completely illustrate this. So we'll have data 2D. then bb, then yeah, 1b, because like I said, this is a member of the derived class now, right? So you should be able to access data 1b, data 2b, data 3. Okay. Furthermore, you can also access the data. Let's try this. So the data 1, 2, 3b, which are the actual members of the base class. Okay, right? So this one is a sort of uh, data of the derived class itself. That can be data in this class. Yeah, 100. So U derived B. So I created a base object, so which will now have these three data members, these three data as the members. Okay, so B has them. When we create D, okay, it has all these members, okay, and the function and everything. Furthermore, because it's a derived class, it has its own copies of these members also. Okay, that's, you don't have to do much. The default constructor will take care of this creation. The essential idea is that how do you create this? That's the main idea. Now let's try to access data 1b. Sorry, 1b, because b does not have d. It has only everything, and ending with b is only the members. Okay, so we can just try to access that data. Okay, now I can try 2, 3. Okay, then I can try d. Okay, which will be data 1 b. No, d 2, 3. That will be 1b. Now remember, this is data 1b, which is a member of class D itself, not the members which are already inside B. Okay, because you have derived class D, which inherits the members of base class. So we can think of like, apart from its own members, sorry, sorry, apart from its own members, the derived class has its extra copy of the base class's variables. Okay, right. And others. Then you can also try to access yeah, 2 and then 3. Okay, so I think we took care of all variables, right? So starting from above, so let's look at this function. Okay, uh, what do you guys think will happen? Like, which one will give errors, or which one will not give errors?
मेरा माइक ऑन है भाई.
Sorry. Okay. Any attempts?
The private ones will be giving the error. The private in the base class.
Private in the base class. Yes, that's correct. That's correct. So if you try to access, let's say this one, data 1b. So data 1b is private, but private to base class, right? So accessing that variable, even if it's derived class, so remember this operator is just this pointer. is just able to access only its own, it's a pointer to the current object, which is a derived class. No matter if even if it actually derives all these objects, it cannot access the private member of the base class. Okay, so this will actually throw an error. There are a bunch of more errors, which I think will be given by
Can
the
we
compiler.
access,
Hmm?
can we access data 3B?
From?
So only the
That's
public
a good question.
variable.
Yeah, that's a good question. Data 3B, but by who? So data 3B itself, yes, base itself can access. Okay, maybe I'll clear this. Maybe I did not say about protected. So data 3B is a protected member. Means it is private to the class. Okay, you cannot access it outside the class because it's not public. It's somewhere between private and public. So it is private. Like you cannot access it outside the class. In that sense, it is private, but it's not completely public, as in you cannot access, like it's not that you cannot access outside. You can access it outside, but only by derived classes. So that is the protected ones. So I'll repeat.
Okay.
Data 1B is accessible by only the base class. So here the class is called base. So the base class can access data 1B because this is private. Data 2B, it can be accessed inside and both inside outside because it's public. Data 3B is accessible only inside by the base class. It is all with respect to only the base class. When you go
Yes, sir,
outside the
got
base
it.
class, yeah, when you go outside the base class, data 1B is not accessible, 2B is accessible, 3B but is accessible, yes, but only by the derived class. So data 3B here, it's fine. It's okay. It can be accessed. This will actually throw an error. Okay, so maybe I'll just run this and you guys can take a look. A lot of errors. Sure. Let's go through them one by one. This is sort of the idea actually. We want to get those errors. The first one is this one. The data 1B is a private member of base. So we cannot actually access this. Okay. But what about the rest of them? Right. So data 1B, again, private member 27. So here, still, again, you cannot access them. We can actually try to get these other data members, okay, which are part of the base class, right? There's these remember when I say this is sorry, excuse me. Yeah, so when I say data 1D by this, okay, so derived is accessing its own data 1D here, which is fine. It's a private member, yes, but derived has access to it. 2D is public one, yes, it has access inside the class. Data 3D, it's private or protected, but that's okay because it can still access inside the class. Till here, these are all private, its own members. Okay, but from here, when you're trying to access data 2B and data 3D, 3B, these are a copy of the base class, not the members, not the ones that are owned by the base class itself, but a copy of it inherited by the derived class. Okay, so to access them, you can use this operator to specifically say which data 2B you're accessing. Is the data 2B which is inside the base, or is it the data 2B inside the current class? Okay. This again gives a better clarity on why even we bother using this operator. Okay. Right. So yeah, let's again, this is fixed, so we can print this and then see the
Got it,
further.
sir.
Yeah, awesome.
Sir, so if you use this operator, it will access the local copy of the derived class.
No, this operator always points to the current object of the class. So you can use this in base also. Nothing stops you.
No, no. So since we are using it in the derived class, it will point
Yeah.
to the variable in the derived class.
No, it points to the operator of the current derived class. So to access the member, so derived class has all these members. It has members data 1D, 2D, 3D. It also
Yes,
has
sir.
members data 1B, 2B, and 3B.
Hmm.
We are specifically say that I'm accessing the data 2B from the derived class. I'm using this operator. Yeah.
Okay, sir.
But I can also access data 2B, but from the base class. So I use the base class name itself to access the base the 2B. But this is the actual, you can think like when we say derived class, all these members are there. Plus there's some hidden members which we don't see it here. In that way you can think. Which are these guys? But
Okay, sir.
the base class itself is also a valid class. So it has its own members. So that's a different data itself, like in memory of RAM and all that, if you want to think that way. Yeah. Okay. So let's call it. Yeah. So again, our data 1B is a private member. So we cannot access data 1B uh, outside the class, outside the base class. So this is also not allowed. So let's combine that. Okay. And then there are warnings, but yeah, we don't need to worry because we're just accessing them and not setting it to anything. So hence the warnings. That's the reason for the warning. For the current case, we don't need to worry about it. But again, if you want to know why that error is coming, why the warning is coming, that's the reason. Because we are just accessing the member, we're not setting it to anything. So which is also not an invalid thing to do, but again, not the most useful thing to do. That's why it gives the warning. But for us, it does the job. We get to see what accesses happen, right? Whichever is the private does not get accessed, and so on and so forth. That's sort of the idea. Okay. Next is this one, which is line 40. So here we see, yeah, data 1B again, it's a private member. You cannot access it outside the class. So we're using the object itself to access these members now. Again, not allowed. I think you can guess data 1D is also private, so you won't be able to access this. There should be one, yeah, data 1D is private, so you cannot access this also, right? Data 1B again, private. Even if D has a copy of it, you cannot access it outside the class. There should be another data 1B. Yeah, this line 48 was an error. Okay, so those are fixed. So let's move on. We'll see other errors. So warnings will ignore. Data 3B is a protected member. Yeah, that's another important distinction. So at here, yeah, sorry, data 3B, while it is access, as you can see here, data 3B is accessible uh, inside the derived class because it inherits it, right? So that's not an issue. You can access it. You can even access it, the variable which is owned by the base. Okay, that is also valid and fine. But you cannot access it outside the class. Okay, because protected is sort of like private and partially public. In that sense, you can remember it. So data 3B outside the class you cannot access. So that again throws there. Okay. And then we have the data 3D. Yeah, data 3D is also protected. So again, exactly the same argument. Protected members, you cannot access them outside the class. Doesn't matter who's accessing. If you're accessing data 3B, which is by the base class, or the data 3D, which is owned by the derived class, neither can access it. Okay, so that is also done. Data 3D, yeah, let's compile again. So it should reduce more errors. Okay, last one. Data 3B is protected member case. Where do we, oh yeah. Again, protect member, you cannot access it outside the base class. Here we are accessing the data 3B owned by B. Here we are accessing, trying to access 3B, which is sort of inherited by D. Okay. Again, protected, so you cannot access. Right? Done.
Okay, sir. So
Yeah.
protected variables
Hmm.
of base class can be accessed only from the derived class,
Right.
and we cannot access them from the main function as well.
Main function means it has to be public because it's outside.
It's a
Yeah.
different function. Okay, yes, got
Yeah,
it, sir.
yeah, exactly. So because when we say main, we are accessing these variables through the object itself. We cannot. So here it's like a local scratch space of your class. You can think that way. So base has its own scratch space from this scope to this scope. Derived has its from here to here. Okay, so that's like a different region where they can access some variables. So private, public, protected, everything's accessible by the class itself, by its own class. But when we go to the main function like this or any other function, the you can access the member variables or the member functions through the object itself, right? But now here the problem is that it has to be public only to be accessible. That's what you see. Okay. Yeah. Private members not accessible. Protected members also not accessible. Only if it is public, you can access them here. There are more nuances because now if we cover this space, which is owned by the derived class, here it can access its own private members, yes, but it cannot access the private members of the base class. even if it inherits everything, actually. Okay. It can access the public members. Yes. It can access the protected members. Yes. That's the limit. That's the property of your protected variables. They're accessible by the derived class. Okay. So you can access them here, but you cannot access them outside like that. It's all consistent, but you just have to be clear about what's the actual definition of each of these. So there are a lot of layers to here. So you have base class. Each of them have their 3 access specifiers. Okay, all good. Then you have derived class. Again, it has its own 3 levels of access specifiers. Right now, how do all these variables, like all these situations, interplay? That's what you have to be careful about. Okay, right. Any other questions? I hope this uh, example clears a lot of things. Yeah.
Yes, sir.
Let me call it 1. I'll make another file. Yeah. So I'll define the base class again. But this time I'll have public section where just, I'll make 2 functions. One takes integer I, okay, and let's say it has its some body where it prints I. Oh, okay, done. Next, I'll define another function which is of void, so it does not return anything. It just takes also a value g. Yes, the function name is g. Takes I, okay. Now it prints 2y. There are simple examples. The point is to again show how the accesses and all those things happen. The actual output itself is not the main thing to focus on. Is there something for the means to end? So when we see I getting printed, and so we know printed, that's when we know G gets done. That's not the idea. Okay. All right. What we can then do is create a derived class. Okay. Very similar to before. Use public this. And then just that's it. We don't do anything else. We can just leave it empty. Absolutely okay. It just means that there is a class called derived, which gets derived from base class. Okay. And the syntax for it, remember, you have to use a colon and write it as public and base. Okay. Now let's define main. We'll create a base object called small b. We'll create a derived object, the derived class D. Okay, that D is an object of derived of class derived, which is again it is a derived class of base. Okay. Now we can call f and pass 6 to it. Okay, we can call g because base has these functions, right? F and g. So we can then call 10. Let's say we do that. Furthermore, because derived class inherits things from base, it not only inherits the member variables that we saw here, it also inherits the functions. So you can also call b dot f, let's say 1, b dot g, and let's say it is 7. Okay. If we can guess what will the output, the what do you call, task here is not very difficult. It's just that the reason to show this example is that you can do this. Okay, that's sort of the motivation. if you have to. Yeah. So the first one prints 6. So f takes integer I and prints I itself. So that's straightforward, right? And the next one, b dot g, it takes 10, okay, and prints twice of that. So that's 20. Fine, that's good. Now the thing is, because derived classes also inherit the same functions, okay, we can uh, use the derived class object D to access those functions and call them. And these are public, so otherwise this nothing of this will be possible. So use D, call F, okay. Now it will print same value, which is 1, and 7, twice of that, so 40. Okay. All right. All right. Mm, yeah. Okay. So hope this is clear. Now, again, I'll give third example. Okay. Something about function overloading. Let's look at what that is. And then build on top of that for this, how inheritance, it works in inheritance also. So function overloading, I'll use. Okay, yeah. Let's say you have a function, some f function, okay, and it is some body. Okay, let's call it body one. Something there. Now, let's say you have the same function, but here it does not take any input. Okay, but here let's say it takes integer input, int I or something like that, and there's a different body or same body or does something. Okay, doesn't matter. So without loss of generality, I can just call it body two. Okay, this is function overloading, where you are using the same function, okay, but giving different inputs to it, and then you can write different function bodies to it. So each of them is distinguishable. Each of the functions, even if they're the same name, they're distinguishable because of the input. Okay, and corresponding to that input, it decides what the body will be. Okay, because we're actually specifying the body here. You can also do it this way, where you have func. Let's say it is row f with some body. Uh, it's written in a comment, but you can think like there's a lot huge body in it or something. Okay, the what it actually does is not the focus. Again, it's immaterial. The point is function overloading looks like this. So let's say it is very important. Okay, and then you can call func. So it will call this one. And when you call func with 1, because it's an integer, they call this. Okay. Right. So this is just an empty body. I'll need to call it inside the main, because without main nothing will work here. So yeah. Right. Okay. Right. Okay. So I guess I can combine this. Okay. Yeah, works. We just don't know which one got called. We can maybe put uh, uh, okay, something like this. I stream is there, so then we put so name this maybe 2, 3, 4. Right. So let's print it. So body 1 gets printed because no argument, so that's the one. Body 2 gets printed because we provided an integer argument. Okay. Right. So building on top of this, maybe I'll just not name it inheritance, but call it function overloading. Right. Building on this same idea, so let's include string. Class base. The same functions of f, g, and all. So f is standard out I, printing I, and 9. And then we have g, which does the same thing. Like it takes the same input, integer. That's the name. Pretty much same behavior. Now prints to 1. To star I. All right. Okay. This so far this is pretty similar to this base class. Okay. Now what we're going to do is change the derived class a bit. Okay. So previously we did not worry about it because yeah, it will inherit everything anyway. So that's just to showcase what happens when you have what happens when you have just a derived class which does not have anything else. It inherits anyway. It inherits variables. It also inherits member function also. That was just to show before. But what if we also have public? Okay, but this time void f, exactly same. Okay, and then with this time the body is different. Will not have the same thing. What we'll do is change to I. Okay, and print I minus 1. Okay. Right. Done. And then very similar G, which takes I, but not as an integer, but as a float. And let's say this does 3i. Okay, so 3 times I, and then finally h. Nothing says that you cannot have extra functions. Like it has to have all these functions only. We did some play with it, like as in it inherits this f and g, yes, and we'll discuss about them a little more. There are more nuances to it, but it also does not stop you from defining more functions. Let's get h here. Okay, let's say this is double. Okay, so see out, and let's say it does I by 2. Okay, all right. The main function is base b and derive d, and then b dot f. So yeah, before I think moving on, one thing I'll clarify. Yeah, because here f is there and there is an f here. It has integer I, this has integer I. Here there is g within the integer I, g with float I. Okay. Now, in the example function overloading, it says that if you have different arguments passed, then it is overloaded. As in all the functions coexist with their own different bodies. Okay. Right? Here, if you think about it, let's take just G. So G has integer I as input. Here it is float I as the input. Okay. So when derived class inherits, so base, I think it's fine. It's just a class defined, so we don't have to worry about it. It has two functions. Okay, that is clear, I guess. But if you take the derived class and the function G, function G exists. There is a definition for integer I. But when you take derived class, it has float I. Okay, so this is for specifically for G. In the derived class, function overloading happens. Okay, this gets overloaded, which means G has two definitions where it takes I, it takes float also. Yeah, integer and a float. Depending on which you pass, okay, it prints either 2i or it prints 3i. Okay, right? Let's take example of that. So let's say I take bf1, and so this is straightforward. It'll take integer, two integers and then print. You cannot pass float to G here from the base class, but you can with the derived class. I hope you understand the difference. Because it is overloaded, you can accept both integer and float. Okay, so sorry, you can call G, but you cannot pass like 0.4 or something. You have to pass 4. Okay. Furthermore, you can access F. Okay. Now here's the tricky part about F, what it actually prints, right? So 6, let's say, D dot H, and let's say just 10, and ends. Now, there is a definition of F with base class, which is this guy. There is a definition of F, which also takes integer, okay, and has a different body. Is this allowed, or is this illegal, or something else will happen? Like what? Any guesses? If you think about it, reason here G is not in, for G it's not a problem because it takes integer, has a different body. Here the G takes a float and has a different body. Okay. Now for derived class, it's not a problem because it can keep both the G's because they're overloaded. But what about F? There is a different definition of F. There's a different definition of F in derived, and both, there's nothing to distinguish except the body. Okay. So when a function gets called, which one will get called? That is sort of the confusion, if at all it arising, and what is going to happen. Any guesses?
It's fine to overload in the derived class.
Okay, why? Any other
The
Mhm.
F function in base class will be called.
Okay. More specifically, the what do you call, the technical term for this will be, it's not overload, it's overriding. So specifically speaking, here the F which gets inherited from here from the base class gets overridden by the definition whichever F the derived class has. As in, you can think like this takes precedence over the definition whatever is provided by the base class. That's it. That's the only difference. So it's not like the F here does not exist, or it how do I put it? It can't be used or anything like that. Nothing like that. It just gets overridden, and this H is just extra. Okay. The good thing about just this G is that it takes integers. It also takes uh, float. Okay, which you cannot do here with B dot G point, with taking 0.6 is not allowed, but D taking 0.6, that is allowed. Okay, because that is overloaded. So first one, F prints I, so that is taking 1 and printing I 1. That is like checked, verified. G takes 4 integer. Okay, that's correct. It takes 2 when then prints 2i. So it takes 4 and prints 2 times of that. So that's correct. And there is some mistake. Oh, yeah, my bad. Otherwise, the inputs and the outputs will not be clear. So let's go again. Yeah, better. So yeah, D, if when we pass 3, okay, so because it gets overridden, it does not print 3, if you see here. So the next here input, it prints 3 minus 1. So it uses this body. So that's confirms that this gets overridden. So that's what we see here. So 3 minus 1, 2, that's what gets printed. Okay. And then when we call G with 6, now it has two choices, which to use. So because G is an integer, it will use this one. So, oh wait, I see. So it actually just uses both as float. Okay. Maybe if I do this, it should be okay. Let's see. Okay, for some reason, G does not refuses to use the inherited one. Okay, in any case, nonetheless, you can actually pass integers and um, float variables to print 3i or 2i accordingly. And lastly, h, with h, you have to pass doubles. Again, this it gets treated as double, and half of it, which is 5, gets printed. Okay. All right.
So can we say J is overloaded as well as overwritten?
Which one? J.
G.
G is not overridden because it still is fine to have two definitions because it has two different parameters. More specifically, G here is overloaded only. But if there was a float version of it, okay, let's say here float I or something existed, then that float version will get over ridden by this float version. That is the idea. It will inherit the integer version. So that will get overloaded because it already has a float version. Again, if you think about it, here it was already overloaded. Okay. G was overloaded here. It also gets overloaded here because you have integer I. It does not have integer I. So it inherits that. And the float version gets uses this definition, not this definition. Okay. Yeah.
Sir, like if two functions have like if there are two functions with the same name in
Mhm.
both the base class and the derived class,
Mhm.
and unless explicitly mentioned,
Mhm.
and it will always prefer the function of its own. Like if we are using the object of derived class,
Mhm.
it will call the function of the derived class, right?
Yes, but is the function signature the same? That is the question. When I
Okay,
say function
so
signature, is the return type the same? Is the name of the same? Is the parameter the same? These three, if they are the same, then yes, it will get overridden. So it will use the base
okay,
classes, sorry, the derived classes body. Yeah,
okay, sir. That's it, sir. Thank you.
yeah, sure. Yeah, that's pretty much what I wanted to cover today. So if you guys have any questions, feel free to ask, or yeah, you can. We'll cover next week. typecasting. So that's also a very important concept in C++. How you cast data types from one to another, be it the inbuilt data types, be it the custom data types, so on and so forth, and how do they play out. So that's what we will be looking at next week.
Okay, sir. Is the class over for today or?
Yeah, it's done. I covered whatever I wanted to cover today. If you guys have any
Okay.
questions, you can feel free to ask. Yeah. I'll just take
Okay.
questions in the rest of the class. Yeah.
Okay, sir. Thank you. That's it.
Yeah. Thank you. Okay, so question, making a class friend is better or making a class derived class or base class is better? When you say friend, remember it's for a function. So um, again, it's not like it's better or um, worse. It's like it depends what kind of access you want. So if B is a derived class of A, so B will have access to the public members, and the members which are protected, yeah, B can access those. Okay, but private members it cannot access. But if it's a friend, okay, if a function is a friend of A, then it can access even the private members. So if you want it to access the private members also, then you make it a friend. Okay, that's the main distinction. Yeah, that's short of it. Oh, inheritance. Oh, it is very much useful. So, for example, uh, if you're familiar with differential equations, so let's say I have a differential equation where it is a Poisson problem. Okay. Poisson problem have Laplacian as the operator. Okay. In that case, you can have a differential equation class, base class. Okay. And its derived class could be specific instance of those differential equations. So, for example, you can make a Laplace operator derived class from the base class as the operator class. You can make Helmholtz operator as the derived class, and so on and so forth. You can make many other kinds of differential equations. For the operator itself can be many other differential the derived classes. So the base class could be an operator class, and you can have Laplace operator as a derived class. You can have Helmholtz operator as a derived class, so on and so forth. Furthermore, because it's a differential equation, you can have uh, different ways of solving the thing. So you can have linear solvers as the base class, and then you can derive a class like a conjugate gradient to use to solve this any of this differential equation. Let's say you can use it. So CG solver, like the solver itself is conjugate gradient. That's a derived class. And then all its members and member variables, everything you wrote. You can make BFGS also, like second order Newton's method. So all these could be derived classes of the base class, the solver. So the problem or the operator itself can be a base class. The solver for solving this differential equation can be a base class, and each of them can then have their own derived classes. That's also something you can use. This is from the perspective of scientific computing. Okay, so and these are real examples that um, I do also work with in my research. So yeah, you can find other examples. Yeah. Okay. This is probably something with architecture. I'm not familiar with it, but I'm guessing ISA is instruction set architecture. I'm not familiar with HASM. Probably it's also some kind of architecture, as in how do we actually implement, or maybe how does the actual hardware uh, represents some kind of code, probably something along those lines. I'm not familiar with it, so yeah. Oh, okay. I think I understood it. Okay. So is A and okay. So derived is a base, apple is a fruit. So you can think like apple is a sort of a special instance of uh, base class. So more, okay, think of it like yeah, it's like classes and objects. You can make fruit as the class and apple as the specific instance of that class. You can do that way, or you can make the fruit as the base class and apple as a derived class. You can also do that. It's all about how you want to design the hierarchy. Okay. Uh, and car has an engine. So car itself has different parts. So engine will be a you can think like it's a member variable. You can think in that way also. Nothing stops you from thinking that it has to be with respect to inheritance only. So apple and fruit, you can relate them using classes and objects, okay, a specific instance of that class, or you can make a derived class and the base class is a fruit and the derived class is an apple. The other thing is you can make car and objects. So engine car has an engine. Uh, car is the class. Engine is the specific member variable. Okay, it has different pieces. So engine itself can be a you can make it engine as a struct itself. Okay, or a class itself, which is a member of the class car, and engine itself, which is a class. Okay, again you can further divide. That is a member of the class car. Okay. I hope that is clear. And also you can make sort of like mm, which specific engine of a specific car. So your derived classes object can be, let's say, a specific model of a car. Okay. And thus your member of your derived class becomes a specific model of that engine. Okay. You can do it that way also. There is no how to put it specific way you have to do it in a certain way. Like all this, you can think of it in a different ways. Okay. I hope that answers that question. I was not getting that. Oh, okay. Yeah. Maybe I read ISA as is yeah. All right. So where to use class? Well, because I can create a function. Yeah, that's actually a good question. So the reason to use class is you keep um, certain variables and certain functions together inside a template, a blueprint. That's the only reason. Honestly, it is okay if you don't use classes. There will be a lot of use cases you will find you don't have to use classes, but it is useful if you use them as in because what all the examples we're saying, right? Derived classes, inheritance, polymorphism, all these things that we're seeing, inheritance, right? So all these have their own features. It's not like you have to use them for a particular problem or whatever use case you have, but it might make it easier if you use them. It's all about learning all these concepts and then using them for a particular problem. You can absolutely create a namespace and put everything together there. So your namespace separates it from the global namespace. So your custom namespace will have all the member variables, all the member functions, and then you can just call that. Absolutely okay. Yes. The reason to use specifically use yeah debugging, yes, those are there. Those things are there, yes. But if you think about it, the use case of a class is to create objects from it. A class provides a blueprint, okay, of how my all the objects I instantiate, okay, from it will look like. That's sort of the idea. So if you have a use case of such a tool from C++, then use it. Otherwise, you don't have to use classes for all problems. Yeah. Okay. I hope that answers it. Yeah. Okay. Good. Yeah. Okay, maybe it's specifically Windows thing that you won't get a compiled binary, which is the exe file, executable file, unless all the compiler errors are fixed. Maybe that is the reason. So typical process of building files is that in C++ is that you write the code, then you compile it using some compiler. It creates an executable, okay, a binary, and then you use that binary to run your program. This is sort of the short process of it. Now it's possible that your uh, generation of your executable is probably not happening because maybe there are compiler errors. So maybe try fixing those and then run. If you are on Windows, it's I'm not very familiar with maybe it is some environment problem, like environment variable problem, or the setup of your compiler could be an issue. You can try using VS Code, and it should auto detect, let's say, C++ compiler if it's properly installed. You can use MingW, Cygwin, and many other tools for this. Or you can also use Windows subsystem Linux, where you can have Linux environment inside your Windows, and which itself comes with GCC, like the GNU compiler collection, like the library. So that has G++ compiler. You can use that also. Okay. You can use that inside the WSL. Try it out. Or else you can have online compilers where you do not have to build anything locally. You can just write your code, run it in an online compiler. It will compile it for you and then print the output, which is also good if you want to just get started. But it is also what I would say is if you want to see and build um, your program, it is sort of easier if you actually build it locally. So I can see the reason why people actually go for that also. Right. Using MSys CRT formation or okay. I'm not very familiar with MySys or MSys 64, but yeah, you can give this Cygwin or MingW a try. Yeah, I'm assuming this is Windows, right? Okay, okay. I see. You can, I guess, just download MingW itself and then install that. I personally feel the best way is you don't have to install anything if you use Cygwin. So because Cygwin comes with pre-compiled binaries, okay, you just have to download it and give the path wherever GCC, G++ is, whichever folder you have in your system. So yeah, maybe you can just use Cygwin. It's been a while I've used it, so I don't remember. I'm not sure if it's still um, developed and kept alive, but it should work. It because GCC, I don't think they should have taken it down. So yeah, you can try that also. Yes. Then you don't have to worry about downloading and it itself compiling some kind of compiler like GCC or so on and so forth. Okay. Only thing you have to do is, I mean, if you want to use GCC or G++ directly, so you can add it to path. That should be done by the while installing if I may say so, installing Cygwin. Cygwin basically downloads all the binaries. So that is the installation process for it. So the binary itself will be the compiler. So GCC or G++. These are compilers which are already compiled. Okay, pre-compiled binaries. So you can like sort of download them using Cygwin and add that folder to the path. That is sort of that's also part of the process of installation. So if you add it to the path, as in the environmental variable PATH, capital PATH. So if you add them to the path, you can access G++ anywhere from your system. Right, right. I'm not familiar of which specifically it will be important, but definitely the modern C++ tech ideas. In general, all these and plus maybe some um, they don't usually use a lot of cores, so maybe it's little bit of parallel programming. Again, I'm not very familiar with it, but it should be taken care of by the whatever what do you call those um, software libraries you use. So yeah, be it Unity or Unreal Engine, you can actually find better lectures online. They'll be able to point you out better. But then again, if you're going with C++, there are yeah, I'm sure there are good topics uh, as to what to cover for it. In general, I would say whatever you're learning from the top for the um, C++ techniques, be it the data structures, be it uh, modern C++ technique, um, modern C++ ideas, they should be transferable. Yeah, it could be game dev. It could be um, working in some projects in some company or in your research. In any case, yeah. Thank you. Thank you, everyone.